Hello everybody and welcome to a tutorial on calculus, and today we're going to be differentiating e to the x and ln x. Okay, so hopefully you've got a little bit of understanding about what those functions are and what they look like. I've got the one y equals e to the x in front of me here, and e to the x is the classic exponential function. For instance, some of its key features are that it exponentially rises, it crosses the y-axis at 1, seeing that e to the power 0 equals 1. Okay, if we put x equals 0 in as our value, then y equals 1. In fact, any exponential function always crosses the y-axis at this point for this reason. Okay, and then we've got the y equals ln x, which is related to e, the number e, because it is the logarithm in base e. Okay, otherwise known as the natural log ln x. Okay, and its graph looks like this. And you can see here it also crosses an axis at 1, but in this case it's the x-axis, which leads us to this result, which is actually, if you plot the two graphs together like so, it's a reminder that these two graphs, these two graphs are reflections in the line y equals x, which means that these two functions are inverse functions of each other. Oops. Okay, so there's line y equals x. Yep. Okay, so just a little bit of background on what those two functions are. And today we are going to be dealing with differentiating with them. Okay, so there's two key results to know, and I'm not going to prove them today because it would take a long time. The derivative of e to the x is actually itself, it's e to the x, which is a really crazy result, really, because what it means is that actually the value of the function, such as 1 here, is actually equal to its gradient. If we looked at x equals 1, such as here, okay, this would be here e to the power 1. So its gradient here is also e. Yeah, okay, and here the gradient is also 1, just like the y value. Okay, so interesting results. And the other thing is to know is that when we differentiate ln x, we get 1 over x. Okay, so nothing really more to say, just to know those things, and we're going to go and practice now some of our differentiation rules that we've learned recently, namely the chain rule, the product rule, and the quotient rule. So let's go ahead and have a look at an example. So differentiate this function. Now we're going to ask ourselves, okay, it's quite a complicated function. It's an e to the x, but actually the x isn't x, it's 8x. Okay, so it's a function within a function, which means that we're going to be using the chain rule for sure. Okay, and we identify the function within the function. In this case, it's 8x. And if we write y instead of f of x, same thing, in terms of u, okay, then it's e to the power u, where u is 8x. Okay, so we sort of deconstruct the composite function. And from here, we can differentiate. So we get du by dx, which equals 8. And we get dy by du, which in this case equals e to the u, because over here, we learned that, I've gone too far, if we differentiate e to the x, we get e to the x. It's still the same, went too far. If we've got e to the u, we still get e to the u. Okay, so whatever that power is, that's it. Okay, so we've got e to the power of u is 8x. And by the chain rule now, all we need to do, if you remember, is dy by dx is equal to du by dx times by dy by du, which in this case is 8 times by e to the power 8x. Okay. Actually, if you want to be, making yourself more efficient in answering these sorts of questions, there's a general result here that we can gauge from this, from the chain rule, which is that if you've got y equals e to the kx, then you differentiate it, you actually get k e to the kx. Okay, it always works. Whether it's 4x, you get 4e to the 4x. If it was e to the 9x that you were going to differentiate, it'd be 9e to the 9x, and so on. It always works. Okay, so if you want to make a note of that, put some stars around it, very useful, very valuable. Okay, next one. Now this is a really easy one because again we know that if y is ln x, then dy by dx is 1 over x. That's the result we've learned today. So if we've got this one, actually this is very straightforward. What we get is 9 times 1 over x, or 9 over x. Really nice example there. Let's look at another one, another nice easy one, which is this one. Okay, so I've got something bit similar going on here. I'm just going to differentiate it. I've got 4. If I differentiate ln x, I get 1 over x. And here I've got minus 5. If I differentiate e to the x, I just get e to the x. So what I've got then is 4 over x minus 5 e to the x as my answer for dy by dx. Again, really, really nice and easy. Okay, so if you've just got coefficients in front of ln x and e to the x, it's really straightforward. Okay, differentiate this function. So if I've got this now, again, what I can see is a function within a function. My function within the function is 2x plus 5. And if I write y in terms of that, I've got ln u. So again, I'm using the chain rule here. All right, now let's investigate what happens if I start to differentiate these things. So I get 2, and I get ln u, so it'd be 1 over u. In other words, 1 over 2x plus 5. Okay, now by the chain rule, we know that we're going to now differentiate those two last results. So we've got 2, we've got 1 over 2x plus 5. So we're going to do 2 times 1 over 2x plus 5. And if you're multiplying a fraction by an integer, it just you only times the numerator by that. So it's 2 times 1 on the top over 2x plus 5. Okay, and again, I'm going to lead you to a general rule here that you can aim to remember, which is, in general, if you've got y equals ln f of x, like a function within an ln, and you differentiate it, look what's happened. Maybe you can spot it. Okay, what we did was we differentiated the function in the function. So differentiate that and it becomes the numerator, f dashed x. And on the denominator, that is just u, isn't it? Okay, that is just the, the function inside. I'm not going to call it u here. I've called it f of x, haven't I? Yeah, that's right. Okay. All right, so whatever the function is within the ln, differentiate it for the numerator and just put it on the bottom for the denominator. And again, that always works. Okay, so another nice result to know. Again, nice for your notes. Get it in your notes, star it. It's very useful. Okay, let's keep going then. So the next one, y equals e to the x squared plus 2. Maybe I'll put some brackets around that just to show it's all one function. Again, it's a function within a function. It's the chain rule. So by the chain rule, first job is to pull out that function within the function, within the main function. In this case, it's x squared plus 2. We've got y equals e to the u. Okay, so now we're just going to go and differentiate these things. We get 2x here. And if we differentiate y, we get dy by du, which is e to the u, or in this case, e to the x squared plus 2. That's what the u was. Okay, you can see it here. Now by the chain rule again, dy by dx is equal to du by dx times by dy by du, which is 2x times by e to the power x squared plus 2. Now again, I'm going to aim to do a general case, okay, a general formula for doing these types of questions a bit quicker. Now what you can see is that basically I've differentiated this and it's become the coefficient. It's become the, coefficient, it's become the term in front of has been multiplied by that original e to the x squared plus 2. So let's try and get that in a general form. In general, if you've got e to the y equals e to the power f of x, right, then what we've got then is dy by dx equals f dashed x, we've differentiated it here, e to the power, e to the power of f of x. Okay. All right, again, could be useful. So, for your notes, star it. Could be useful in the future. All right. And it makes sense by the chain rule, doesn't it? Now, I've just set a couple of questions here to give you a bit of a chance to practice. I have gone about 100 miles an hour through that. So feel free to pause the video, go back, look at those general rules that I've just mentioned, and perhaps you can have a go at finding the answers to these before me. Okay, so feel free to pause. I will be back soon. Okay, all right, so I hope you had a go. I'm going to reveal the answers now. Let's see how we did. First of all, you can see this is the derivative of 4x to the power of 4 plus 9 is this on the top, and then the function on the bottom, that's what we said. Here we've got the derivative of 3x to the power of 5 plus 2, which is this, and then just the function itself. Okay, so I hope you got those. That's nice. Okay, let's continue. Now, again, another function. This one involves an e to the x, and this one is not a chain rule, is it? Because what it is it's two functions sitting side by side. And I hope you realize that the operation between these two functions is that they're being multiplied together. Okay, now when we multiply two things together, we're talking about a product. So we're going to be using the product rule here. Okay, where the product rule says if you've got y equals uv being two functions, then dy by dx is uv dash plus vu dash. So we've got to go and find those things basically. We've got to go write down what u and v are. That's very easy. U is e to the x and v is the square root of x. Now for differentiation purposes, I'm going to change that to x to the power of a half. And let's go and find the values of u dash, so the derivative of u with respect to x, and v dash, the derivative of v with respect to x. Okay, this one's dead easy. We know this now off by heart. And this one is half x to the power of minus half. All right, so by the product rule now, we're going to go and put them into this. I know these four things, 1, 2, 3, 4 things. So dy by dx is going to be half. If I'm going to put the half, just because it's a number, I'm going to put it in front. So half, now I've got e to the x, x to the power minus a half, plus, now these two things multiply together. So I've got plus e to the x, x to the power of a half. You could leave it like that, nothing wrong with that. You could tidy it up slightly because there's negative powers, which always annoy me a little bit. So e to the x over, what would it be, 2 root x plus e to the x root x. Yeah, I mean, you don't have to do that. That's all one thing. You don't have to do that, but if you wanted to, just to tidy it up slightly, there's nothing wrong with that first answer, actually. That's fine as well. Okay.